My name is Jay Dickerson. I'm the director for the Center for Social Justice Education here at USI, and I'd like to welcome you to our presentation today. Today's presentation is about disability and assistive technology. This is the second in the Let's Talk About series that the university is funding to put on this year. And so I'd like to welcome everybody and again apologize for the lack of pizza. It was not expected. So to get started today, because we are on a short amount of time for the room, I'd like to welcome Rick Nelson from the Easter Seals Rehabilitation Center. And today he's going to be speaking to you about assistive technology. So if we could please give Rick a nice warm welcome.
Thank you very much. Can everybody hear me okay? All right. Good afternoon, everyone. Thanks for being here. It's quite a crowd, I guess bigger than what we expected maybe. And yes, I am a rehabilitation engineer at the Rehab Center. Depending on what I'm doing, sometimes I do more engineering than other times. There's just so much commercially available equipment, hardware and software now to help people with disabilities that a lot of times it's just being aware of what's available and putting it all together in the right package. And this is the mission statement for the Rehab Center. Yeah, basically we do all the therapies there. We have a durable medical equipment business. We have the assistive technology program. And we just do our best to increase the opportunities for people with disabilities to help them be more functional, more productive, more safe in their daily lives. And I do clinical work, which is my sort of day-to-day, working with people one-on-one, evaluating their situation and helping to meet their needs. But then for the last 5 or 6 years, we were lucky enough to have a person come into the Rehab Center to help us with overall programming and a lot of the different departments. But he saw the abilities of our assistive technology program and told us about this government grant program, and that has allowed us to do some research and design work. So I'm going to first talk about the clinical work that I do and some of the hardware and software that's available, and then at the end we'll talk about an R&D project that we just finished up with over a period of about 3 years. So in the clinical practice, I work in all of the areas of assistive technology, computer access, which is obviously helping people with various disabilities to access a computer to do work or school, home modifications, going in and making people's homes accessible, vehicle modifications, wheelchair seating and mobility, which is where I got my start 30 years ago, and then job accommodation. Job accommodation can really be a hodgepodge of everything. You never know when you go into somebody's workplace what kind of equipment they have to use, how they're going to get from home to work, and is the building accessible, things like that. So in computer access, it can be, and all of my slides kind of show representations of low-tech, middle-tech, and high-tech hardware and software, just to give you guys a feel for everything that's available. So it could be as simple as providing somebody with another means to access the mouse and control the cursor on the computer screen. On the upper left, that's a Kensington trackball. The ball is about 2 inches in diameter, and so people don't have to be able to use their hands and fingers to roll it. They can use their elbow, their foot, the back of their hand, the side of their hand, and then there's some software that goes along with it. So that trackball is programmable, so you can change how quickly the cursor moves on the screen, so people who don't have very good coordination can still control it pretty well. And then it's around that ball, it's got 4 buttons, and those buttons are programmable. So if somebody doesn't have the ability to double click the button, you can program one of the buttons so a single click is a double click. And there's all kinds of things you can do with those, but you can make one of the buttons actually, you can create a macro with that button so it will do a multiple key operation like Control-Alt-Delete or something like that if people can't hold those keys down. And then next to that on the top is a depiction of an on-screen keyboard. The on-screen keyboard software is very versatile. It puts the keyboard on the computer screen, and then if it's a touch screen, the person can just do direct select and they can type right on the screen. If a person is very limited with their movement and can only maybe move their head to hit a switch, then you can set up those on-screen keyboards so that they scan through the rows and the columns to do the selection for the key. And then the lower two slides are a little more high-tech. This gentleman here is a high-level quad, doesn't have much movement below the shoulders at all, but he uses voice recognition software to access a computer. And the software is called Naturally Speaking, and there's different versions of it, but with all of the versions, you can use your voice to do everything on the computer, even control the cursor movement. So all you have to be able to do is speak. And then this person here is also that same level of injury and is not using voice recognition software, but a person like that can still access a computer. What he has is a sip and puff switch in his mouth, so he can puff for left click and sip for right click, and then that dot on his forehead, when he moves his head, that communicates with the computer and moves the cursor. And then there's software, if a person can't use the sip and puff, but they can still move their head, there's some software called dwell click. So all you do is you move the cursor over to what you want to click on, and if you dwell for a certain amount of time, the computer understands that you want to do a mouse click to open up that program. So very low tech to very high tech, so you can really set a computer up for just about anyone. In home modifications, I just did a home modification evaluation yesterday up in Jasper. It can be as simple as a wheelchair ramp. This girl has got a new power wheelchair, and they live in a mobile home, and it's really high off the ground. And their only concern was, how are we going to get the wheelchair in and out of this mobile home, and can we widen a couple of doorways? And so that one was really relatively simple. We just designed a wheelchair ramp. We know which doors that need to be widened. But then a couple of years ago, I did a home modification eval on a young mother of 4 whose husband was, very busy, worked 60, 70 hours a week. She's a homemaker with these 4 young children. She was in a sledding accident and became a paraplegic. And so when we went into her home, it's 2 stories, so we had to put in an elevator. We had to modify her bathroom with an accessible shower. We had to set up the washer and dryer so that they were at heights where she could reach them. We had to do, and so it was more, it was more complicated than just a ramp. In fact, for her, we did 2 ramps. She had to be able to get out in the backyard with the children, and then she needed to be able to get into the front entrance of the home as well off of her driveway. And then, when we want to make a sink accessible, it could be as simple as with that gentleman there, just cutting the cabinets out below the sink all the way down to the floor, and then you move the plumbing back. Or for this mom that I was telling you about, she wasn't the only one in the home that did the dishes. So if we were gonna, for her, and if we were gonna cut underneath the sink to allow her wheelchair to access it, we were also gonna have to drop it down. But if we dropped it down permanently, then it was gonna be hard for other people in the home to wash the dishes. So we had to provide her with a sink that goes up and down. So, and then this is a pantry that's got shelves that rotate. So there's shelves behind, so you can store a lot more in that pantry than it looks like, and you can bring the shelf down to the level of a person who's sitting in the wheelchair just by hitting a button. And then that's a cooktop that can go up and down as well. So, if her husband was cooking and he's tall, he would want it up, but then she can hit a button and lower it down. So it goes from, low tech to kind of middle tech to more high tech with home mods as well. For vehicle modifications, I do some work in that area. We have an occupational therapist, Jessica Schulteis, who is also a certified driver's rehab specialist. She does most of the vehicle evals because most of the referrals we get are people who actually need to drive the vehicle. And so that takes a lot of on-the-road training that is her specialty. I do the evaluations when someone just needs to be a passenger in the vehicle and they're not driving. But it can be as simple as on the upper left, that's just putting a hand control lever. So that if you're a paraplegic and you can't use your feet to push the gas and brake pedal, then that lever is attached to the steering column, and then there are 2 rods that come down from that lever. I think you can see it sticking out on the left-hand side of the steering wheel. One rod goes to the gas pedal, one rod goes to the brake pedal. So when you push that lever forward, it puts on the brake, and when you rotate it down towards your thigh, it accelerates the vehicle. Also, if a person is in a wheelchair and can't transfer from their wheelchair directly into the driver's seat, which is the case a lot of times because the driver's seat is generally a lot higher than the wheelchair seat, so that transfer is difficult, then you can put a wheelchair lift on the vehicle, so that would be the upper right. Also, There's a company called Braun and several other manufacturers. They can take minivans and they can lower the floor 10 to 14 inches. That does two things. It gets the floor down lower so then you can just use a ramp to drive your wheelchair up in as opposed to a lift platform. But then it also gives you more headroom. You know, a lot of times if a person is in a power wheelchair, they tend to sit up higher, so you have to lower the floor so the person can get in and sit upright. And then once the person gets in a vehicle like that lower floor minivan, they make seats that the driver's seat where the seat will move back and forth, it'll move up and down, and it will pivot. So they can drive their wheelchair into the vehicle and then transfer into a seat that's like the seat that you and I sit in that's crash tested, it's just as safe, it's got lap and shoulder belts. That's the preferable method. Not all people can do that transfer, so we can set a vehicle up so that someone can actually stay in their wheelchair and just pull right up to the steering wheel and drive. The only disadvantage there is that it's not quite as safe because they're not sitting in a crash-tested bucket seat. And then on the bottom right, that is a representation of very high-tech driving controls. There's a company called EMC, Electric Mobility Corporation, and they provide technology that allows you to drive a vehicle with a joystick. And in this situation, on the left-hand side, that's a joystick that does gas and brake. And you can set it so that gas is forward or backward, depending on the person's abilities. And then on the right-hand side is a little horizontal steering. So this steering and gas and brake are kept separate. And whenever you're doing a high-tech driving evaluation, you want to keep steering and gas and brake separate whenever you can because it's much safer. But I don't have a slide of it, but this company does make, they call it the J series for joystick. It's if a person can only use one hand and they can drive a powered wheelchair, then they can use a joystick to drive a vehicle as well. It's just not quite as safe because the steering and the gas and the brake aren't separate from each other. So it takes hours and hours of training. And sometimes those people don't get beyond the ability to just drive around their neighborhood because once they get up to a certain speed, they can't control it. So, seating and mobility is where I got my start 30 years ago. I'll get maybe at this point probably to give you a little bit more background on me. I got into this working for a durable medical equipment business about 30 years ago. I actually worked for a couple different ones, and the very first thing I did was wheelchair seating and mobility. Of all the areas of assistive technology, seating and mobility takes the longest to learn. I've got an engineering co-op student who's been with me for about a year now, and he'll be with me for another year. And by the end of those 2 years, he's with me about 12 or 14 hours a week. He will be pretty good at computer access, environmental controls, home modifications, you know, some of those kind of things, because it's a little bit more limited in what's available and what you can do to solve people's problems. But seating and mobility, it took me 3 years really doing it full time to get comfortable with it. And when my co-op student graduates, he's still going to have a long way to go with seating and mobility. He wants to be a rehab engineer, so I know he's going to stick with it, but that's an area where he's going to have to go on and get some additional training through going to conferences and things like that. But it could be, for wheelchairs, it could be as simple as just a standard mid-wheel drive power chair on the upper left with just pretty standard seating. That the upper center is a power wheelchair that's got power seating on it, so if a person has to be able to tilt back or recline to do pressure relief occasionally so that they don't get pressure sores over their sitting surface, then they can do that automatically through the joystick. They just put the joystick in a different mode. Or it could be as complex as the iBot, which doesn't, it's not available anymore there on the upper right. The iBot was a great idea. It was just very expensive and insurance wouldn't fund it. So after trying to market it for a couple years, Johnson & Johnson decided to put it to rest. But the iBot, I don't know if everybody's seen it or seen a video of it, but it has gyroscopes and backups to backups, and it would actually stand up on two wheels, and it could go through sand, gravel. Those wheels would rotate around each other so it could actually climb steps. And in order to purchase an iBot, you actually had to have a representative come, and you had to get it in the chair and go through a 2 or 3 hour training session to see if you were capable of using it before they would consider selling it to you. That's how complicated the chair was to use. So, and then on the lower is just a very simple manual wheelchair. that chair is pediatric. It tilts in space. This would be for a child or an adult who can't drive a power wheelchair for whatever reason, can't propel a standard manual wheelchair, but they still need to be positioned with lateral trunk supports and headrest. And so that's an example of a tilt space chair with just very simple seating, just flat, linear, just someone who doesn't have very good balance, maybe not very good head control, and they just need a little extra support and maybe need to be tilted back sometimes during the day when they get tired and need to rest. The seating can go from that simple linear to the center. There is a molded seating system. For that would be for someone who has skeletal deformities of the hips, pelvis, spine, and flat seating just doesn't support them because it doesn't touch them everywhere. So in that case, we put the people in a molding frame and create a custom molded seat. And that has really evolved over the years. 25 years ago when I was up in Michigan, working in a seating clinic, and that's actually where I went to school. I went to the University of Michigan my degree is kind of a combination of engineering and design, and then I did a 12-month internship in the rehab engineering program at the University of Michigan Hospital. So it took me 6 years to get my degree because I was kind of in the School of Engineering and the School of Design, and then did that internship. So my degree is kind of custom because I knew going in that I wanted to be a rehab engineer. I didn't want to just be a regular old mechanical engineer. So back then when I was working in the seating clinic, when we would mold someone, once we were done molding them in this molding frame with these molding bags, they would go home and then we would lay plaster over the seat in the back and create a negative. And then we would have to put that in a box and send it to Minneapolis. And then they would take that negative and make the positive cushions out of it and then send it back to us. So it was a very tedious process. Today, it's all done digitally. When the person gets out of the molding frame and leaves, I take a digitizer wand that looks like a pen with a little button that you push, and I just use that. It's hooked up to a laptop, and I just use that pen, and I go over the surface of all the contours of the seat in the back, and I create a digital file, and I email it to them. And then they make the cushions on a computer-aided milling machine that cuts foam, and it used to take 6 or 8 weeks. Now it takes about 10 days or 2 weeks for people to get their cushions. So it's moved along. And then next to that molded seat is just an example of an air bladder seat cushion for people who are paralyzed, who can't move and shift around like us, and their muscles aren't innervated, so their muscles are very flaccid, and the bones tend to sink in and cut off blood flow. They're very susceptible to skin damage and pressure sores, and there are all kinds of wheelchair seat cushions, from foam to gel to air, to help people be more comfortable and more healthy when they're sitting in their wheelchairs. Job accommodation, like I said earlier, that could be computer access. It could be designing, as simple as designing a ramp so somebody can get into their workplace, or as simple as putting a power door opener. That would be the upper right, so that someone can get into the building or get into their office. It could be designing a custom workstation for a person who works in a restaurant, a chef, or a stand-up wheelchair to allow a person to access the computer and the shelves with all of their equipment. So sort of low, middle to high tech. So it could really be a combination of all the different areas of assistive technology. And those job accommodation evals tend to be, in some ways, more interesting than some of the others because you never know what you're going to get into until you get there. And then, like I said earlier, along with all of the clinical work that I just described and all of that kind of hardware and software that's available, I do a little bit of engineering, but not a whole lot. But with the R&D work, that's where I really do the majority of my engineering these days. The program that funds that is SBIR. It's Small Business Innovative Research. All of the government agencies, like all of the branches of the military, National Institutes of Health, Department of Education, they all have to take a portion of their budget and put it into the SBIR program. And if you're a small business and you think you have an innovative idea, but you don't have the funds to pursue it yourself, then you can write a grant proposal and submit it, and it's competitive. So you don't know whether you're going to get funded or not. And they fund it in phases. Phase 1, they typically give you 6 to 12 months and $75,000 to $100,000. And in phase 1, you're basically just doing enough to show that your idea is feasible. So you just create a very simple bench model or a very simple prototype, and you test it to the extent that you can say, yeah, this idea is going to work, or no, it's not. And if your idea does show feasibility, then you can apply for a phase 2 grant. They typically will run up to 2 years and can be up to $700,000-800,000. And that's where you really get the nitty-gritty work done and create a fully functioning prototype that can be fully tested, including human subject testing, and then hopefully marketed to a manufacturer and made available to people who need it. So this is our pet, VARPO. VARPO stands for variable position. Typically, when a consumer needs a power wheelchair these days, they have to choose between rear-wheel drive, mid-wheel drive, and front-wheel drive. There's no wheelchair on the market where you can automatically move the drive wheels through a range that allows for true rear, true mid, and true front. All those drive wheel positions have very distinct advantages and disadvantages. Mid-wheel drive, the turning radius is very small, it turns on a dime, so they're very good indoors. When you get outdoors in a mid-wheel drive chair, because when the drive wheels are in the middle, it's the person's weight and the whole center of mass of the wheelchair, and the person is right over the drive wheel, so it's like being on a teeter-totter. So you have to have front and rear casters on a mid-wheel drive chair. And with front and rear casters, the problem is when you get ready to go over rough terrain or you get ready to transition up a ramp, the casters want to lift the drive wheels off the ground. And then you lose traction, and so you lose your ability to go anywhere you want to go. So, that's a very distinct disadvantage for mid-wheel drive chairs. And when mid-wheel drive chairs first came out, the manufacturer did not put enough play in the ability for the front and rear casters to move up and down to compensate for that. And so they learned very quickly that mid-wheel drive chairs couldn't go up very steep ramps unless you got a running start and kind of coasted through that period of time when the drive wheels are off the ground. So then the manufacturer started playing around with putting in suspension systems and pivot points and things like that so the casters could move. And that improved their ability to go up ramps and through obstacles. But then the person who's driving it is, it's not very stable. And people who don't have very good head and trunk stability, like people with muscular dystrophy, they couldn't drive mid-wheel drive chairs, even if it was better indoors. Even indoors on flat ground, just the starting and stopping, it was throwing them off balance. And then with front-wheel drive chairs, you've got the drive wheels in front, so they're much better with curb climbing and obstacle climbing because you've got those big wheels that kind of cushion the blow. Plus, they'll roll over curbs easier just because they're bigger. They tend to be a little bit difficult for people to drive that don't have very good control of the joystick because of all the geometry and the location of the center of mass in relation to the drive wheels. They get pretty squirrely. So very often you'll find that front-wheel drive chairs don't go as fast as rear-wheel drive and mid-wheel drive because the higher the speed, the more squirrely it gets. And then as far as turning radius, front-wheel drive is kind of in between rear-wheel drive and mid-wheel drive. It's got a pretty good turning radius, so they do pretty good indoors. A lot of times people who have perceptual difficulties, people with cerebral palsy, don't keep very good track of what's behind them, and so the problem with front-wheel drive with them is that when they get ready to turn through a doorway, they forget that they've got these rear casters, and then the rear casters hit. And then rear-wheel drive is the largest turning radius, so it's the worst indoors. But outdoors, it's got great traction. It'll run through gravel, mud. We've put it through all kinds of material. And the rear-wheel drive, for a lot of people, tends to be more intuitive to drive. So it's easier for somebody with perceptual difficulties, in some cases, to drive it. So all three drive wheel positions, very distinct advantages and disadvantages. And we thought, well, why can't we combine all of those advantages into one chair? So that's VARPO. So there's VARPO in rear-wheel drive, and you see in rear-wheel drive, the rear casters come up off the ground, and now they're anti-tippers. And then in the middle, it's in mid-wheel drive, so now all four casters are on the ground. And then on the far right, it's in front-wheel drive, and so now the front casters come up off the ground. And when the rear casters come off the ground, they just come off the ground an inch or inch and a half because that's about where you want anti-tippers to be. In front-wheel drive, they come about 3 or 4 inches off the ground because in front-wheel drive, that's when you're wanting to climb curbs and other obstacles, and so you want those casters to be high enough so that they don't stop you from climbing whatever it is that you want to climb. And then the other little nuance that we learned in this project is that, and then those are the 2 bottom figures, those are the rear suspension springs, and you can see that they're at different angles. If you change the angle of the spring, it changes the effect that the spring has on the suspension system. So when you're in mid-wheel drive and you want to limit the bridging effect of the drive wheels being lifted off the ground, then you have the springs rotated at an angle like they are there, and that makes the suspension softer. But when you're in rear-wheel drive and the rear casters are off the ground, it doesn't matter where the springs are. But then when you're in front-wheel drive, what happens is if the rear suspension is too soft in front-wheel drive, when you start the wheelchair moving, the rear suspension squats and it compresses the springs. And when the wheelchair stops accelerating, if the suspension is too soft, it doesn't recover fully. So those springs are still loaded. And then when you let go of the joystick to stop the chair, it's almost like getting launched out of a catapult. The springs release all their energy, and sometimes they'll even come off the ground, depending on how quickly you stop. So we learned pretty quick that with Varpo, we were going to have to make our springs angle adjustable. So that, and that, luckily, we didn't learn that until after we got funded, and we didn't really have that worked into our budget, but we kind of twiddled some things around and took a few things away, and we were able to afford the additional cost of making those springs angle adjustable. And okay, that's the end of my presentation, other than I have a video to show you of Varpo. It's about a 10-minute video, and then that'll leave us plenty of time at the end, 20 minutes or so for questions, answer, if anybody wants to come up and speak with me. Okay. All right. We need volume. Oh, here it is. Can everybody hear okay?
The front casters come up. Notice also how these
Okay, is that there? We'll go back to full screen. Right there.
Start it over.
Yeah, okay, that better.
going from rear to front wheel drive.
Is that better?
Notice how the front casters come up. Notice also how the suspension, the rear suspension goes from the soft to hard position.
So that's sort of showing how the rear suspension springs change their
Going
angle.
from front wheel drive to rear wheel drive, notice the casters going down and up, but also notice the suspension in the back, how that is softening. Mid-wheel drive, 36-inch hallway, 32-inch doorway. The actual total time for this is 41 seconds. This has been edited down.
Here we were doing maneuverability testing in the different drive wheel positions just to show
Front wheel
how much more
drive.
maneuverable mid-wheel drive is.
The total time to accomplish this task in front-wheel drive was 59 seconds.
And as you'll hear, it,
Cut out
from mid to front to rear, the
make it
time it takes to do the task kept increasing. And then the level of difficulty. When we did the human subject testing, this is just me, we eventually took this to Louisville to Fraser Rehab Institute, and they had some of their clients in it, and we asked them, not only did we measure the time it took, but we asked them about perceived difficulty
rear-wheel drive.
on a scale of 1 to 5.
36-inch hallway, 32-inch doorway. This took a minute and 26 seconds.
So we went from 40 seconds to a minute and 26 seconds.
41 seconds mid-wheel drive, 59 seconds front-wheel drive, in a minute and 26 seconds.
And you can see too, if I was in a home, I would be tearing the walls up.
Also, there was a little bit of extra fixing up of the pathway, so it didn't take forever. Of a series of curb binding clips, and we use curb attack as well, so it's not always head-on. You can see that sometimes it works and sometimes it doesn't work when we come at anything other than a 90-degree angle.
So in mid-wheel drive at a sharp angle, sometimes you can't even climb the curb. And then see how much easier it was in front-wheel drive. Rear-wheel drive did it, but it was quite a jolt and really had to get a running start. We actually bent a few front forks on this as well. Yeah, and then there, mid-wheel drive wouldn't even go. And this is that's the biggest curve we climbed, and we only did it in front-wheel drive. We knew that rear and mid wouldn't do it.
One option is to stop when you see you're getting into a tough situation. Here we're in mid-wheel drive, we stop and we move to rear-wheel drive, and then we start driving as we go out into the open field, which we manage just fine. We go through a pretty nice little rut. Here we start from the same position in mid-wheel drive, going slowly, and you'll see we don't make it through that rut.
That little rut wasn't very deep.
We
But,
switch to
mid-wheel drive wouldn't do
drive after we're stuck, and then as you'll see, we are able to pull out of the rut.
That's another advantage of having a wheelchair that has drive wheels that move back and forth. If you happen to be in the wrong drive wheel
We're able to
position,
go through the rut
and you
then
get
we're
stuck,
at high speed.
a lot of times you can get unstuck instead of having to sit there and wait for help.
In slow speed front wheel drive. Now we go through the rut slow in rear wheel drive. Going slow in mid wheel drive, got stuck.
That's really deep gravel.
Moved it to rear wheel drive
4 inches
and
deep.
pulled out.
So there again, we got stuck, we put it in a different drive position, we backed out, and then we just barreled right
Going
through.
slow again in mid wheel drive. Got stuck in the soft gravel. Changed to front wheel drive. And then again, we're able to work our way out. Front-wheel drive going through the softest, muckiest stuff we had as a combination of leaves and soft gravel. Now we're going to go through it in rear-wheel drive, we're going pretty fast. And then we try it in mid-wheel drive and we are stuck and we never did get out of this.
That gravel was so deep,
Switch to rear and to front.
we got stuck, and we couldn't get
Get
unstuck.
out. And the reason
But that was the only time that we ever got stuck and couldn't get ourselves unstuck by moving the wheels back and
We're
forth.
able to get out.
I think this video shows us on a rainy day in the mud, too. I hope it does. I haven't watched this video in quite a while. Yeah, there it is.
Stuck in a rut, small little rut in mid-wheel drive. Going, what speed were you?
Moderate.
Yeah. Stuck in rear-wheel drive, in front-wheel drive, switching it to rear on this slope. Going to try to get out, and this is very wet, soft ground, so we're now switching it to rear-wheel drive. Let's see if we can go now.
We got some pretty weird looks of people driving by that
Back it
day.
up.
This is another one of the situations where I didn't think I was going to be able to get out of it.
Let's get the hell out of here and go in the half. Well, that's not even good though, actually.
My colleague Bob Levy, I wish he was here.
We're having an interesting time here.
He's a character. He actually got a PhD in experimental psychology. So he doesn't,
What do you
he doesn't
think?
do a whole lot of engineering.
Okay, we're gonna try front wheel drive, just get out of here, you might want. But this is mud, this is soft. It's very, very wet, we've had 2 or 3 inches of rain. Okay, let's see what we can do now.
I got out, but I barely got out.
Okay, we're going in front wheel drive. This is really nasty out here. You gonna go through that rut and come out? Okay, we're trying for the rut. Coming through. Okay, and then we're gonna just go out of here. We hope. Well,
I'll stop the video here.
the joystick, you change.
Well, no, and this is kind of interesting. We,
Notice that
originally,
they drop, they come down.
when we built Varpo,
Rear-wheel drive.
we knew that you could change the drive wheel position on the fly
And
mechanically,
then notice
but
further.
we couldn't do it because we had to stop and put the joystick in a different mode. And we changed the drive wheel for the joystick.
And there you go.
So we decided to add this other joystick that's dedicated to the drive wheel position so that you can change the
We're
drive
gonna
wheels.
switch to front wheel
while
drive.
driving. We had some people, some human subject testing we did here.
Ground.
They told us that they wanted to be able to change it on the fly. At that time, when we did our
Okay,
human
so now we're
subject
gonna
testing.
go ahead. Here we are.
So we added that before we took it to Fraser Rehab Institute.
Wheel drive, we're in mid-wheel drive. Now we're changing to front wheel drive on the fly. Because we saw we were coming to some rough territory, and there we are. It's
Okay. I'll go ahead and stop it. There's not a whole lot more there.
here, mid-wheel flying the hill.
Okay. One thing that we learned, and we have a phase 1 grant proposal in for this other powered wheelchair idea that we have. My colleague at Fraser Rehab Institute, where we did the human subject testing, I actually worked there for about 3.5 years before I went to the University of Michigan in the occupational therapy department. And I didn't know Mary Ellen Bunning at that point because she was in Pittsburgh. But now Mary Ellen Bunning, she's got a PhD in occupational therapy, but she really specializes in assistive technology and wheelchair seating and mobility. So she did the human subject testing for us, and it took about 5 days. And so I was in Louisville with her and an engineering student of hers for that whole time. And so we had a lot of discussions. And Mary Ellen and I decided that if we had to have a powered wheelchair right now, after seeing people drive Varpo and driving Varpo ourselves, we would choose a rear-wheel drive chair. Even though they don't do very well indoors, the rear-wheel drive chairs have a lot more pros than cons, and they have a lot more pros compared to the pros of mid-wheel drive and front-wheel drive, in my opinion, and Mary Ellen agrees. So that learning experience, even if Varpo, we're trying to market it to some power wheelchair manufacturers, even if that never occurs and Varpo is never made available to the public, we have another idea, and it's this phase 1 grant proposal that we're waiting to hear back on. I hope it gets funded, to take a rear-wheel drive chair and just make it better. And I can't go into a lot of detail on how we intend to try to do that because we don't have patent protection right now. And so I can't disclose it publicly. But it was the 3 years that I worked on Varpo, I learned a lot about power mobility. And in fact, it was easy to get the phase 1 for Varpo because it was a fairly high-tech idea. It was kind of breaking ground, and it was the Department of Education, and they maxed out at $75,000. So they thought, yeah, we'll give you $75,000 and see if you can do this, you know. And in phase 1, it wasn't like Varpo. It wasn't automated where you hit a button and they move. Well, I had to get out of the chair, go behind it, turn a crank to move the drive wheels back and forth, and it took a while. And then to move the casters up and down, I actually had to have 2 wrenches and loosen bolts and move things up and down. So, you know, it got us where we needed to be with our testing, but and we call that Varpo 1. But Varpo 2 was, you know, much nicer. But anyway, through all that experience, one of the things that the phase 2 comments, whenever you apply for these grants, whether you get funded or not, you get the comments back from the reviewers. Because if you get funded, some of the comments may help you change a few things to do a better job. If you don't get funded, you can take the comments and try to redo your proposal and resubmit it, and you can resubmit up to 3 times before they say, no, we're never going to fund this thing. But when we got our phase 2 approval and we got the comments back, there were a couple of the people who said, you got to be very careful. Don't make this thing too complex. Don't make it too expensive because then insurance isn't going to pay for it, like the iBot that I showed you earlier. But one of the guys said, even if this is never commercially available for whatever reason, just think about what we're going to learn about power mobility. And he was exactly right. From my perspective, and Mary Ellen Bunning and my colleague Bob Levy, we did learn a lot about power mobility. VARPO might be on the edge of being too complex, and even though it's worthwhile, and of the 12 human subjects, 11 of them said they want to take VARPO home today. One guy was an old quad who had a rear-wheel drive chair for 30 years, and that's all he wants, rear-wheel drive. Just stubborn, but anyway, we learned that this other idea we have does have the potential to make a better rear-wheel drive chair so that it's more maneuverable indoors, but more stable and more versatile outdoors, and technically much less complicated than VARPO. So at some point, maybe a year or 2 down the road, I can come back and show you another video of whatever we end up calling it. So I'm done with my formal presentation. Anybody have any questions or?
I have a question, and forgive my ignorance of engineering, but would it be possible or feasible to have an all-wheel drive chair?
They're available.
Like you do with an all-wheel drive car?
There's a company called Innovation in Motion, and actually it's one of the companies that we're going to try to market VARPO to because they're used to high-tech wheelchairs. They have a wheelchair that's 4-wheel drive, and when you steer a regular powered wheelchair, it's called differential steering. Basically, one drive wheel spins faster than the other, or one spins in reverse and one spins forward, and that's what makes the chair turn. Okay, but the Innovation in Motion all-wheel drive, 4-wheel drive, it steers just like a car, like with rack and pinion, and they do it with actuators, and that's about a $30,000 chair. But we have been able to get 2 of those funded through Indiana Medicaid because one guy, he's a quad, guides people turkey hunting because you can still put a call in his mouth, and if he can get out in the field in his 4-wheel drive chair and get behind a blind and use that mouth call to call turkeys in, he gets paid to guide hunters. So, it was his job. So Indiana Medicaid funded that, and then there's another guy who makes turkey calls, and he needs to be able to get out into the woods to test his calls. So we use that as the justification. Medicaid funded it, but it's, $32,000. They're expensive chairs.
So you want one just take up turkey hunting? Is that
And they come in camo.
Figure out about how much your chair is going to cost as compared to just a normal rear wheel?
Our estimate from talking with some people who sell wheelchairs and a couple of power wheelchair manufacturers is that VARPO would probably be about the same cost as a power wheelchair that's got the power seating like the power tilt, power recline. Those chairs tend to be around $18,000 to $20,000, and so then we anticipate that that's what VARPO would probably sell for if it was commercially available.
Does this chair have the tilt as well on it?
But our seat, because of funding limitations, you can change the recline and the tilt, but you have to do it mechanically with nuts and bolts. So we did some testing at various angles because that does affect the center of mass and the tipping stability, especially backwards and forwards.
Can you pick an already existing, like say a standing wheelchair, and add any of those movements to it? Because I know, like, my brother has a standing wheelchair that was around $40,000, and I believe he's got the mid wheel.
Yeah, generally the standing chairs are either mid or rear.
Yeah. Would there be any way to ever add that so you didn't have to pay for another $2,000?
The VARPO feature with the drive wheels that move back and forth? Possible. It would take a lot of R&D work, beyond the scope of the SPIR funding. That would be a manufacturer taking their own in-house engineers and their own funding and working towards that. You know, maybe starting with one chair that does it, but work towards it being a kit.